All right, number 1. Well, the instructions on 1 and 2 say give the requested components for the polynomial. So on number 1, it gives us this polynomial, x to the 5th minus 9x squared. It asks us the degree of each term and the coefficient of each term. So for the term x to the 5th, the degree is the exponent. Well, for any term, the degree is the exponent, the coefficient is the number in front. So for x to the 5th, our degree is 5, and the number in front of x to the 5th, since there's not 1, would be 1. The degree of negative 9x squared, our second term, is going to be 2. The coefficient, which is the number in front, is going to be negative 9. So that would be our answer on those. On number 2, it asks us for a little bit different information. It says that the degree of the polynomial. So the degree of the whole thing is the biggest exponent. Okay, because the polynomial is this whole thing, whereas a term would just be the 3 parts of this. So if it asked us for the degree of each term, we'd do what we did up here. It asks us for the degree of the whole thing, which is the biggest exponent, which is 4. Then the leading coefficient is what's in front of the biggest exponent. So since this was our biggest exponent, this 4, the leading coefficient is negative 2. Most of the time, it will be the very first number, unless it's not in standard form. Remember, standard form means to count down 4, 3, and get lower as you go through. So this was in standard form, so negative 2, which the first number was. But if it wasn't in standard form, put it in standard form first, and then the leading coefficient is the first number. Number 3 should hopefully be an easy one. Find f of 3 means you put 3 in where x is. So that's 3 cubed minus 3 times 3 squared minus 4 times 3. That's a lot of 3's. Type it into your calculator or work it out by hand. 3 cubed is 27 minus 3 times 3 squared, which is 9. 4 times 3 is 12. 27, 3 times 9 is 27. So these cancel each other out, and we're left with negative 12. 27 minus 27 is 0. 0 minus 12 is negative 12. So that should be our answer. On 4 through 7, we are using the leading coefficient test to determine the end behavior of the polynomial function. And so I have here the chart that we made in our notes, or that was given to us in our notes. And this is something that you should either write down or memorize so that you have it for the test, because it will be very important to have it. So what you do is you look at just the first term. We want to know is the degree, which means the exponent, is the degree, is the degree, which is the exponent, odd or even. So this exponent is even, so we look at this case, the even degree, and then we look at the coefficient. Remember, the coefficient is the number that's in front, and so this is a positive 3, so that's a positive coefficient, which means our end behavior is rises to the left, rises to the right. So you look for which one that is. Be careful, because it'd be silly to pick the right one on here and then pick the wrong answer choice. Our answer should be D. Number 5, we look at this first term. We look at the degree. It has an odd degree, so that's odd degree. We look at the coefficient. It's a negative 6. So the negative coefficient, that means that this rises to the left and falls to the right, which is B. All right, look at 6x cubed. That's an odd exponent, so that's odd degree. It's a positive 6 for the coefficient, so positive coefficient. It falls to the left, rises to the right, which is answer choice D. Falls to the left, rises to the right. Look at negative 4x squared. The squared there is an even exponent, so even degree. Number in front is negative, so it's a negative coefficient. That means that it falls to the left, falls to the right, which is answer choice D, falls to the left and falls to the right. On 8 and 9, the instructions say, determine whether the graph shown is the graph of a polynomial function. If a graph is a polynomial function, that means that it is smooth and continuous. Those were the words we used to describe it. Continuous means you can draw it without picking up your pencil. If you start to trace this graph, which you may or may not do a good job like I did, I've got to pick up my pen or pencil and then start drawing again. So this is not continuous, which means it is not a polynomial function. By smooth, that would be a graph that's not smooth. I mean, it would be a graph that like has a point. That's not smooth. Okay, so this is not a polynomial because it's not continuous, but the other case of not being a polynomial that we need to remember is that it's not smooth. On 9, if we look at this graph, it looks smooth. It doesn't have any corners, and also it is continuous because I can sit here and I can trace this badly without picking up my pencil, and so that means it is a polynomial function. All right, number 10, add the polynomials. Okay, there's two ways you know you're adding here. It says add in the instructions. There's a plus sign in the middle. That's how we know to add. And when we add polynomials, we are adding like terms. So we need to look through here and look for our like terms. So negative 5x to the 7th has the like term of 9x to the 7th. And when we add these together, we just add the numbers in front. Negative 5x to the 7th plus 9x to the 7th is 4x to the 7th. When you're adding like terms, you do not change the exponent that the x has, because this is like saying you have $9 and you took $5 away, well, you end up with $4. The thing that's next to the 4 stays the same. So next, my next set of like terms, I have 5x to the 6th. I have negative 7x to the 6th. So 5 minus 7 is negative 2x to the 6th. And then we have negative 5x to the 5th minus 8x to the 5th. Negative 5 plus a negative 8 is negative 13x to the 5th. And then last, we have a positive 9 minus 8, which gives us a plus 1. So this is our answer, 4x to the 7th minus 2x to the 6th minus 13x to the 5th plus 1. It's a little bit different now when we subtract the polynomials, just a little bit. There's a minus sign in the middle here. But what we want to do is we want to make this easy on ourselves. So we're going to change this to a plus sign so that we can do what we did in the previous problem. But in order to change that to a plus sign, we have to change everything in the second parentheses, all of the signs. So if it was a positive, it changes to negative. If it was a negative, it changes to positive. So now we're going to leave the first parentheses alone, but the second parentheses is now this. And then we add like terms like what we did on 10. So 9x to the 6th plus a negative 6x to the 6th gives us 3x to the 6th. And then negative 5x to the 5th plus 3x to the 5th is negative 2x to the 5th. Negative 7x to the 4th plus 9x to the 4th is 2x to the 4th. And then last, 9 plus 1 is 10. Now this is a problem that's really easy to mess up because you have to change the signs in the second polynomial. You have to change all the signs to the opposite of what they are originally, or you're not going to get what it is. So now 12 and 13. We are multiplying our monomials in 12, so that means to take this in part, 7 times negative 11 is negative 77. When we multiply things like x squared times x to the third together, we add the exponent, so that'd be x to the fifth. So here where we have x squared and x cubed, that gives us x to the fifth. And remember, this y has an exponent of 1, so y to the first times y to the fourth, you add those exponents together, and you get y to the fifth. So negative 77, x to the fifth, y to the fifth. 13, we have to distribute. So 6x to the fifth times 11x to the fourth. 6 times 11 is 66. X to the fifth times x to the fourth, you add the exponents and you get x to the ninth. Then distribute some more. 6x to the fifth plus 7x cubed. 6 times 7 is 42. X to the fifth, x cubed is x to the eighth. And then 6x to the fifth minus 8 is negative 48x to the fifth. And that right there is our answer. Number 14 seems a little to be a tough one for people to remember. So here's what you do. You take, it's kind of like foiling but more complicated. You take the x and you distribute it to everything in the second parentheses. So x times 5x squared is 5x cubed. X times 8x is 8x squared. X times 4 is 4x. But then you have to keep going because you have to also distribute the 3. So 3 times 5x squared is 15x squared. I like to write that right here so I can see my like terms. You can just write it here at the end, but I like to write it underneath. So 3 times 8x is 24x. 3 times 4 is 12. So the reason that I wrote these where I did was so the x squareds would line up and the x's would line up. So now we can add like terms just by looking down our columns. This is 5x cubed. This is 23x squared, 28x, and then 12. So it's not that hard if you know what you're doing. It is a little bit longer of a problem though. 15, use FOIL. Well, what does FOIL mean? It means first, outer, inner, last. So first, x times x gives us x squared. Outer, x times 6 gives us 6x. Inner, negative 3 times x gives us negative 3x. And last, negative 3 times 6 is negative 18. Always check your middle terms to see if they're alike, and they should be. X squared plus 3x minus 18. Now, on 16 and 17, it says to multiply using one of the rules for the square of a binomial or by foiling. We had these rules that are in, I think, the 5.2 notes, if you wanted to go and look, that says we can, that's not right. A plus b squared is a squared plus 2ab plus b squared. And so that's one way we can multiply this, is by basically figuring out what is a and b in this situation from this side, and then we fill it in on this side, and then we simplify. The other way of doing it, though, is to just FOIL. We'll get rid of this squared and say it's really x plus 7 times x plus 7, and then FOIL. So you get x squared plus 7x plus 7x plus 49. Add your like terms and get x squared plus 14x plus 49. If you're using the formula, well, a has to be x and b has to be 7 because we had x plus 7 squared. So then you fill this in. A squared is x squared plus 2 times a times b, so 2 times x times 7, plus b squared, so 7 squared. You just simplify this real quick, and we end up with the same thing that we got foiling. The other formula, the one with the minus, is this. The only difference in the two formulas is the signs. So in this case, it's a little bit trickier actually if you use your formula, because people tend to make a pretty big mistake. So if we FOIL, 12x times 12x is 144x squared. 12x times negative y is negative 12xy. Negative y times 12x is negative 12xy. Negative y times negative y is plus y squared. So we've got like terms in the middle. Negative 12 minus 12, those have the same sign, so you add them together and keep the negative sign. So this should be our answer. Now, if we use the pattern, we have to say, okay, A is 12x, B would be y, because it's 12x minus y. But when you fill it in here, you have to put the 12x in parentheses. Because 12x, when I square it, needs to become 144x squared, like what we got when we FOILed. So it's a really easy mistake to not square the 12 and just have 12x squared. Well, that's not what it is. So whichever way you want to do that is fine. There's the formulas if you want to write it on your little 3x5 note card. And last of multiplication. The rule for the product of the sum and difference. So that rule looked like this. And so we can just FOIL this and say 9x times 9x is 81x squared. 9x times negative 8y is negative 72xy. 8y times 9x is plus 72xy. 8y times negative 8y is negative 64y squared. Add your like terms in the middle. They cancel out because it's negative 72 plus 72, which is 0. So we get 81x squared minus 64y squared. If you're using the formula, you have to figure out, okay, well, A has to be 9x and B has to be 8y in all of these cases. So that means that we have 9x squared minus 8y squared. So we have to actually square the number and the x, the number and the y. And now the moment we've all been waiting for, factoring. Factor the greatest common factor from the polynomial. So that means, what do these terms have in common? Like with the numbers, look at the numbers and say, what's the biggest number that we can divide into each of those? You may be inclined to say 2. We can divide a 2 into all of them, but there's a bigger number. We can actually divide 4 into all of them. So we write down 4 because we know we can divide all of them by 4. Then we look at the x's and we say, how many x's at most can we take out? This first one has 9 x's. That's what x to the 9th means. The next one has 7 x's, and the last one has 2 x's. So if we're trying to take out the same amount from each, we can take out 2 x's. So we take out an x squared. Then we write what is left over. And so to do that, what we're basically thinking about is if I divide by what I'm taking out, that's what we mean by taking out, that we're dividing. So if I divide, then what is left over here? So 20 divided by 4 gives me 5. X to the 9th over x squared, you subtract those exponents and you're left with x to the 7th. Negative 28 over 4 is negative 7. X to the 7th over x squared is x to the 5th. And then 32 divided by 4 is 8. X squared over x squared cancels out completely so that there's not an x there. We close our parentheses, and that is our answer. Now we need to, on 20, factor by grouping, because anytime there's 4 terms, we have to factor by grouping. That's the only way we know how to do it. So we look at these first 2 terms and we factor out the greatest common factor, like what we did on 19. We say, what do these have in common? There's not a number in common because x cubed only has a 1 in front. So we can take out an x squared. And if we take out an x squared from x cubed, that leaves us with x. If we take the x squared from 4x squared, that leaves us with 4. Now, when we group these two together and figure out what we can take out, we want to take out in such a way that our parentheses end up having the same thing in both sets. So you may say, oh, I can take out a 3, and that's true, but we actually want to take out a negative 3, because that means if I take a negative 3 out of the first one, I'm left with a positive x. If I take a negative 3 out of negative 12, I'm left with a positive 4. So our parentheses here match up. They're both x plus 4. So what we're doing now is we're actually taking that x plus 4 out. That's our common factor for these two things, x plus 4, and then we write what's left over, which is x squared minus 3. If all it asks you to do is factor by grouping, then that's all you have to do. Like, don't try to take this any farther. Whenever we want to take things farther, remember the instructions say factor completely. That's your indication that there's probably more than one type of factoring that you can do. But this is the answer. We don't want to try to factor anymore at this point. 21 and 22, we're factoring the trinomial. So we have to remember when there's three terms here that we are trying to put into two parentheses, where if there's not a number in front of y squared, we're just saying, okay, put y's in front. What multiplies to get 14, that will add to get us negative 9. Well, all the things that multiply to get 14 are 1 and 14, 2 and 7. Which of those adds to get 9? 2 and 7. But we need to make them both negative so that when we add them together, we get a negative 9. So our answer here is y minus 2 times y minus 7. Not too bad as far as that goes. And then 22, same deal. Still trying to add, multiply. Okay, and so we've got a's in front this time. So what all multiplies together to get 1 and 27? 1 and 27, 3 and 9, and that's it. And so since this is negative, either we've got to make the first number or the second number negative. Well, 3 and 9 are 6 apart, so that's going to be the one that we have to use. So we need to figure out, is it 3 minus 9, or is it going to be 9 minus 3 that gets us a positive 6? Well, it's 9 minus 3, so we use a plus 9 and a minus 3 for our answer. Now, factor the trinomial, and it even gives us a humongous hint here that we need to either use slide and divide or the box method to factor the trinomial. And I think for the most part, we've been using slide and divide. That's the way I like to do it. You take the number in front and you slide it to the negative 5. So that means multiply. X squared minus 9x, 2 times negative 5 is negative 10. Then you factor like what we just did. Put x in front. We say, what do I multiply together to get negative 10? That will add to get negative 9, or subtract is another way of thinking of it. So 10 is 1 times 10, 2 times 5. If I'm trying to make one of those negative, then I need to think about how do I subtract to get negative 9. I have to use this right here, and we would say, well, is it 1 minus 10, or is it 10 minus 1? So it ends up being 1 minus 10. So we put plus 1 minus 10. But we did the slide part. Now we need to do the divide part. So we take what number we started with up here, this 2, and we divide both of these by 2. And the way this works is if it doesn't actually divide, we try to simplify if we can. And if we are still left with a fraction, we put the bottom number in front. So this is 2x plus 1. But this one does simplify. 10 divided by 2 is 5, so this is x minus 5. And that's our answer. Now here's where we start getting kind of a little trickier. Like on 24, this has come up a lot. If there are two terms, we have to use a pattern. Okay, and it even tells us which one to use. Difference of two squares right here. What's going on in this pattern is that we have 81x squared equals this a squared at the front. Okay, and 64 equals the b squared. And so in order to fill in the rest of our formula, we have to figure out what a and b are. Well, to figure out what a is, we're basically square rooting both sides of our equation. And so that gives us, for a, 9x, because the square root of 81 is 9, the square root of x squared is x. And for b, the square root of 64 is 8. So if we fill in this right side, we have a plus b, which is 9x plus 8, and then a minus b, which is 9x minus 8. And that's our answer. So you have to remember, if you can take the square root of both terms and there's a minus in between, that you split it up like this. The same thing in both sets, but one's a plus and one's a minus in the middle. 25 and 26, factor the perfect square trinomial. There's also patterns for those, but really it's just as easy most of the time to just go ahead and factor like normal, where we say, what do I multiply together to get 4? That adds to get 4, which has to be 2 and 2. And then on this one, what multiplies together to get 100? That will add to get negative 20. X minus 10, x minus 10. Okay, arguably some of the toughest ones for us to get for some reason, because again, we have to use these patterns. We have to understand what's going on. So if I have x cubed minus 8, I'm using the pattern with the minus sign right here. And the reason I know this is, for one thing, it says in the instruction to use the sum and difference of two cubes, and look at what the title of this is. You need to put this on your card, by the way, because you're not going to have it, and otherwise you probably won't know how to factor this. So we have x cubed minus 8. So if this is supposed to match up, then a has to be x. Okay, because what cubed gives us x cubed? Well, we put an x in there, and now it matches up. Then what cubed gives us 8? Well, 2 cubed would give us 8. So b is 2. And the way you can figure that out is on your calculator. You can press the math button and go to option, I think it might be 4. It's the cube root button. And you're going to take the cube root of 8, and your calculator will tell you that it's 2. Okay, so once you figure out what a and b are, you put those values everywhere in your pattern that a and b occur. And I know that's kind of hard to read, but here's what, so we'll write it over here. A minus b is x minus 2 times a squared, so that's x squared, plus a times b. A times b is x times 2, which is 2x, and then b squared. You can put in 2 squared, but we need to do 2 squared. We know what that is. 2 squared is 4. So that gives us a 4 there. So this is our answer to how to factor x cubed minus 8. Now, this second one is a little bit tougher, and partially because they use little a's and b's, and here we've got big a's and big b's. But we'll have to try to make it work. So we're trying to basically look at this and think about what is the cube root of this term. So if I cube root both of these, I'm left with a times b. Okay, so our big A from our formula is AB, little a, little b. And then if I take the cube root of 125, most of us probably don't know that off the top of our heads, so we do it on our calculator and we get 5. So we're using this formula, and we just figured out, okay, the big A is AB, the big B is 5, and then you fill it in everywhere, and it's really not going to work for me to try to write over that. So A plus B is, you fill in this plus this. When we square it, you have to square both parts of this. AB squared is A squared B squared. Minus these two things multiplied together. So that's 5AB plus B squared, so plus 5 squared, which is 25. All right, 29 and 30, use factoring to solve the quadratic equation. So it tells us, hey, factor this. So the key thing is we have to make sure everything's on one side of the equation and that the equation equals 0. And so in 29, that is the case. We need to figure out, hey, what multiplies to get negative 40? That will add or subtract to get us 3. So let's think. What multiplies to get 40? 1 and 40, 2 and 20, not 3, but 4 and 10, 5 and 8. That's all of them. So which of these, if we subtract them, do we get 3? 5 and 8, and we need to figure out, is it going to be 5 minus 8 or is it going to be 8 minus 5? We need 8 minus 5 to give us a positive 3. So this is plus 8 minus 5. And that's what we did on other problems, but here's the thing. We're solving this equation, which means you take the parentheses, each one of them, and set them equal to 0 and solve. So x plus 8 equals 0, subtract 8 from both sides, and you get x equals negative 8. Add 5 to both sides, and you get x equals positive 5. Now on 30, we have to start off by getting everything on one side. So move the 30 over to the left side by subtracting it. That gives you x squared minus x minus 30. And since we did 30 minus 30, we have 0 on the right side. Now we can factor by saying, what do I multiply together to get 30? That when I subtract, I end up with negative 1. Well, we need to use 5 and 6, and we figure out, hey, is it 5 minus 6, or is it 6 minus 5? Should be 5 minus 6, which gives us a negative 1, which is what's in front of x. So, plus 5 minus 6, set those equal to 0, and solve. So now we solve and get x equals negative 5, solve, and get x equals 6. So that's our answers, negative 5 and 6. I hope you've enjoyed this video of the Chapter 5 review, and I hope you make a grade on our test.